Because of the continued replenishment or recharge by precipitation, the water table in an unconfined aquifer is at some scale related to the topography. Two major groundwater flow regimes can be distinguished, as shown in this figure. From piezometer readings, one can observe a topography-controlled water table, the upper figure A, where the water table closely follows the local topography as a subdued replica. Alternatively, with a recharge-controlled water table, the lower figure B, the water table does not follow the local topography, but does follow the regional topography. In other words, it follows the topography at a cruder scale. In the Netherlands, during my student days, so quite some time ago, the groundwater flow regime, which one is the correct one, was the cause of much debate. Later it turned out that both regimes can occur. Simplified from work by Hadjema and others, the degree to which the shape of the water table is topography controlled or recharge controlled largely depends on the ratio of the recharge rate and the aquifer transmissivity. A high ratio, thus the recharge rate is relatively large, the aquifer's transmissivity is relatively small, is favorable for the establishment of a topography-controlled water table, the upper figure A, whereas a low ratio, the recharge rate is relatively small, the aquifer's transmissivity is relatively large, is favorable for the establishment of a recharge-controlled water table, the lower figure B. Thus, when the conditions are right, a relatively high ratio of the recharge rate over the aquifer's transmissivity, local, intermediate, and regional flow systems may develop in a drainage basin as shown here. The time of contact of groundwater with the subsoil influences the chemical composition of the groundwater. The groundwater's chemical composition at different locations may be established from a relatively simple-to-use chemistry toolkit in the field, and is most useful in establishing the groundwater's origin and whether the groundwater at these locations and at a specific time is part of a local, intermediate, or regional flow system. The latter activity is part of hydrological systems analysis, an analysis of the close relationships between land use, groundwater recharge, vegetation patterns, groundwater flow systems, water quality, and surface water networks.